All right, so today we're going to talk about the average rate of change. Now, we can use either one of these two formulas for the average rate of change. You may recognize this formula, right? This one you used in geometry. This is just your slope formula. And you actually use this in Algebra 1 as well because you did do average rate of change in Algebra 1 as well. Okay, so just to start off, I'm going to stick with using this formula. All right, so let's take a look at the first one, number 50. It says determine the average rate of change in miles per hour from 2 to 4 hours on the graph shown below. So we're looking at the average rate of change from 2 hours to 4 hours. Now, these right here are my x values, right? They're along the x-axis. So if we're going to use this formula right here, then these are going to be my x values. I'm going to label the first one x1 and the second one x2. To be honest, it does not matter which you label which. Now, let's just look at these points on the graph, right? When x equals 2, the corresponding y value is 20. And when x is 4, the corresponding y value is 60. All right, so since I already said that we were going to make the x value of 2, x1, and the x value of 4, x2, then whatever y value corresponds with each of these, right? So since 20 corresponds with 2, I'm going to call this y sub 1. And since this is the y value that corresponds with our x value of 4, right? Since 4 is x sub 2, I'm going to call the 60 y sub 2. Okay, so now what we're going to do is take these numbers and plug them into our formula. So in the numerator, it says y2 minus y1. So that's going to be 60 minus 20. Okay, and then in the denominator, we have x sub 2 minus x sub 1. So that's going to be 4 minus 2. And then you could just figure out what this is equal to. So on the top, 60 minus 20 equals 40. And in the denominator, 4 minus 2 is equivalent to 2. And since 40 divided by 2 is 20, we wind up with 20, and then you have to put your units. Now let's think about this. Since the y is on top, isn't the y representing miles? And since the x's are on the bottom, isn't the x's representing hours? So your units would be miles per hour. Okay, it'd be miles over hours. And if you prefer to write that, since we usually say that miles per hour, if you want to write it as 20 miles per hour, that would be fine as well. Okay, we're going to skip over the next few examples. If you can turn to, what page is this? Page 30? Yep, if you could turn to page 30, we're at the top of that page. So number 54. Okay, so it says the distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows the stopping distance for various speeds. Okay, now in letter A, it says determine the average rate of change. So right away, I know I'm going to be using this formula. In braking distance, in feet per mile per hour, between one car traveling at 50 miles per hour and one traveling at 70 miles per hour. All right, so they're giving us 50 miles per hour, which we see is right here. Okay, and they give us 70 miles per hour, which I see is right here. Now, when we look at this table, right, the first column is going to represent our x's, and the second column is going to represent our y's. So they are giving us the two x values. So I'm going to label these x sub 1 and x sub 2. Now, if we look at what y values correspond with each of these x values, we can label them y sub 1 and y sub 2. Okay, these are just subscripts. That's why I'm saying sub. Okay, some people just say y1 and y2, but all right, now let's plug our numbers into the formula. So let's see. In the numerator, make that big, we're going to do y sub 2 minus y sub 1. So we're going to do 306.25 minus 156.25. Okay, and then in the denominator, right, we're going to do x sub 2 minus x sub 1. So 70 minus 50. All right, and then you could just figure out what that's equal to. So if you subtract the numerators, I guess that gives you what, 150? Yeah, 150 exactly. And then if you subtract the denominators, it gives you 20. And then 150 divided by 20, or, I guess 15 divided by 2 would be 7.5. So remember, for our units, since the number on top is our y values, the y's are represented using feet. So that's going to go on top. And since the number on bottom is the x values, right, the x is measured in miles per hour. Now, honestly, they gave you that in the problem anyway. So, see right here, in feet per mile per hour. So we honestly could have just gotten it from here as well. All right, part B wants to explain what this rate of change means as it relates to braking distance. Okay, so first of all, I just want to go back and point out our units are feet per mile per hour. So basically, if you're traveling between the speeds of 50 and 70 miles per hour, right, you're going to need more braking distance the faster you're going. So if you're traveling between the speeds of 50 and 70 miles per hour, a car's going to need, on average, it's important to say average because this is the average rate of change, a car's going to need, on average, an additional 7.5 feet to stop for every mile per hour faster that it's traveling. Okay, so I just, this is how I said it. When traveling between the speeds of 50 and 70 miles an hour, an additional 7.5 feet is needed to stop on average for every mile per hour faster a car is traveling. Okay, so you need an additional 7.5 feet to stop for every mile per hour faster that the car is traveling. And it is important to say on average, and it's also important to say between the speeds that the car is traveling. All right, so if you can turn to the bottom of the next page, page 31, we're going to take a look at number 57. So 57 says, which function shown below has a greater average rate of change on the interval from -2 to +4? Now, when they're written in brackets like this is telling us the start of our interval and the end of our interval. So this represents the first x value where our interval starts, and this represents the last x value where our interval ends. So basically, x sub 1 is -2, and x sub 2 is +4. Okay, so we're given two functions. One of them gives us a table of values, and one of them gives us the equation. Okay, so let's start with this one, f of x. So we know that our x sub 1 and our x sub 2 are -2 and +4. Okay, so -2 is x sub 1, and +4 is x sub 2. And then the y values that correspond with these would be our y sub 1 and our y sub 2. All right, so let's plug these into our average rate of change formula. So we're going to do the change in y's, so 80 minus 1.25 over the change in x's, so 4 minus -2. Now, 4 minus -2, if you have a minus negative, isn't that really just plus, right? So when we subtract these out, it's really going to be, so 80 minus 1.25 would be 88.75 divided by 4 plus 2 is 6. And 88.75 divided by 6 gives you 13.125. Okay, so that's the average rate of change for f of x over our given interval. Now for g of x, honestly, I think the easiest way is just to go to y equals in your calculator and plug in this equation and just look at the table of values. See how they give us the table of values here? Look at the table of values. All right, so in the calculator, I just went to y equals and I plugged in the equation. And then I hit second graph. I went to the table of values, and we can see here is my x1 and x2. and my y1 and my y2. All right, so for g of x, let's do the same thing. Let's find the average rate of change. And notice I'm not writing g of x equals, right? I'm putting a little dot semicolon here because I don't want to say g of x equals this, right? G of x equals this. Here, I'm just showing what the average rate of change is for g of x. All right, I don't need to rewrite the formula because we have it right here. So we're going to do y2 minus y1. So that's going to be 179 minus negative 49. And remember, when you have a minus negative, it becomes a plus. So this time I just jumped into making it a plus. And then on the bottom, we're going to have 4 minus negative 2. So just 4 plus 2. All right, so on top, 179 plus 49 would be 228. And on the bottom, 4 plus 2 is 6. So if I take my numerator and divide it by the denominator, I wind up with 38. Now, we don't need units here because there's no units. It's not a word problem. But to go back to the question, they want to know which one has a greater average rate of change. Well, we can see that 38 is greater than 13.125. So g of x has the greater average rate of change. All right, so there we go. I just wrote it out. G of x has a greater average rate of change. And I would state the interval because it might not always have a greater average rate of change if we were looking at a different interval. So I would definitely state the interval. All right, and the last one we're going to take a look at today is number 60 on page 33. All right, so this one looks like a little word problem. So it says that the function n of x can be used to predict the temperature of a cup of hot chocolate in degrees Fahrenheit after x minutes. What is the approximate average rate of change of the temperature of the hot chocolate in degrees per minute over the interval from 0 to 6? All right, so they want us to find the average rate of change over this interval. Now remember, when they give us an interval in this form, right, this represents the beginning of our interval, and this number represents the end of our interval. These represent the x values. So this is x sub 1, and this is x sub 2. Okay, so, just like the last one, in g of x in the last one, right, they give us an equation. So the first thing we're going to want to do is in our calculator, we want to go to y equals, and let's plug this in. All right, so here we go. So we know x sub 1 is 0, x sub 2 is 6. So let me just label the corresponding y values that go along with these. All right, so if we use our formula, y2 minus y1 over x2 minus x1. All right, so we could write out y2 minus y1 over x2 minus x1. All right, so then when we subtract the numbers in the numerator, we get negative 53.59. And when we subtract the numbers in the denominator, we get 6. All right, so then when we divide these, we wind up getting negative, I'm going to say, actually, I'm going to erase this. Have you guys ever seen this symbol? This is the approximate symbol. I'm going to be rounding here. We get approximately negative 9317. Okay, so if we look at the answer choices, we could see, look at that, that matches up right here with choice number 1. Okay, and I just want to point out, here we have a negative average rate of change, and it makes sense in the context of the problem. Think about it. We're talking about the temperature of a cup of hot chocolate. Wouldn't the temperature in the cup go down and down and down over time? So it's decaying, okay? So the average rate of change is approximately negative 8.93. If they had said, what is the average rate of decay? Like, look at this one down here. What is the average rate of decay? When they say the average rate of decay, it would be 8.93 because the word decay takes care of the negative.